Hi, this is Sion the Rapadant from Rapadant Industries. Today I'm going to be showing you different components you might find on a motherboard or a PCB board of any kind, not necessarily computers, but some other things too. I'm also going to show you a few different types of hardware and some key things about them that you might want to keep in mind when dealing with them. Okay, so to start out, I'm going to start with this PCB board that I got laying down here. I'm going to use this screwdriver. I'm going to point at, anything on the board, like a capacitor, for example. This is a capacitor, and what that does is it stores electricity until a certain point and then discharges it, on the path it goes. Now, this is a choke. If I'm remembering correctly, this is meant to filter out certain frequencies that might be inside the actual current going along with it. If that's wrong, I'll probably leave an annotation on screen about it or in the description, which everything will be in the description. So, this is a die. This is on a processing unit, like say a CPU or a graphics card's GPU, a sound processor, stuff like that. This is PCI EX16. PCIe is PCI Express. It's the successor of PCI, which is this one right here. PCI was much slower. I'll leave the speed rates in the description below. So, if you need to, just pause the video, go over to the description, just look, go back up. You know. See, there we go. This is a fan plug. Now, not only fans can go here, you can put LED light strips as well. You can put a water cooler pump, which I have a water cooler I'm going to show you as well. And it basically powers up the fan, and in some cases lets you change the speed it's going at. Like say it's going at 300 normally, and it can support up to 600 RPM. You can set it to actually use the full speed, which some people say noise is the issue. I would I would strongly suggest just keep it away from, where you're at when you're using it if noise is an issue. Otherwise, it's going to be silent, yes, but you're not going to get as much performance out of it. That's why I generally say if you're going to get hardware, don't use things such as sound or how it looks. I mean, those things are some pretty nice things to get, but go with performance first. Next, cost, and if sound is involved, just get that later down your list of priorities, alright? Now, this is an IC. This is basically a thin little sheet of silicon or carbon. I think they use that too. But basically, it's got a bunch of tiny little components. I'm not real sure on that, but they do various things. Um, and basically, it just travels along on the bus. And the bus is probably can't see it in this, but it's like these tiny little lines right here. They're like little wires inside the board with a layer of epoxy over it, and that is essentially your bus. Not to be confused with the yellow ones that run down the street and go to normally schools. I believe they go to other places, but that's not important right now. Okay, moving on to the next little bit. It's on another part of the board. There it is. VRMs. VRM is voltage regulator modules. They ensure that power is supplied to the CPU, the various components on the board, to the bus, to the north and south bridge, which I'll show you that in a moment. But anyways, VRMs are essentially power controllers. Like the power supply unit, they're essentially smaller ones on the board itself, distributing to the various parts of the board. This is a choke, and essentially frequency filtering, and then the capacitors next. It goes into that. But the first thing it hits is the actual VRM chip itself, which are these tiny little square shaped chips. Now, this board is a three-phase. Is it free? Yeah, I think it's. Yeah, I believe this is a three-phase one, because normally the more chokes it has, the more phase. That phase is. Yeah. Sorry about that. Having a little bit of an issue with my voice. Been losing it lately, but enough of me. Back to the components, right? So this is a three-phase board. I just got it out of trash, but those are VRMs and what the VRM area would look like and how it would function. It'd go from the chip to the choke to the capacitor and then to the actual components it's needed at. This is the socket. You'd place your CPU right there, and that's essentially it. You'd line up the little arrow on the chip itself with the arrow on one of the corners. On this board, it's on this corner right here, and you just line it up to where the arrows are right on each other. And first you'd have that up, but you'd have this up, line it up with the corner, push it in, and then close. From there, you'd take your back plate. This is a back plate. And then it would go right under there. Be very careful when applying back plates because they can sometimes scratch your bus, and I've had boards to where I scratch the bus and something gets broken and something doesn't work. In that case, I got lucky and I only lost 2 of my RAM slots. But the thing is, I could only use 2 RAM sticks. So I went from having 24 gigs of RAM to having 16. I was using 3 8 gigs and a 4 gig. And, wait, I'm sorry. I have failed you at math. Anyways, I was using 3 8 gigs and a 4 gig. And I lost 2 of my slots and could only use 16 gigs. And that was kind of a problem at the time because I used a few VMs and a RAM disk as well. And I couldn't anymore. And I still need to replace that board in that machine. Now, on to back plates. A back plate is essentially 4, sometimes more. I've never encountered one with more than 4 or less than 4, but the shapes of it do vary, which is really annoying, and that's kind of because of Intel and AMD. So, but anyways, so the back plate essentially keeps the board flat. The little plastic thing on here, the insulating thing, is a little messed up, but I'm trying to get it flat as possible for you. This essentially lets the board sit on there, provides you the 4 sockets you'd need to put the screws in for the cooler, and keeps the board from bending a little bit, which is kind of nice and useful. Now, what I like about the back plates are this little thin layer here is insulated, meaning it's perfectly fine to touch the CPU, or not CPU, but the motherboard, and it just sits there, and it doesn't short anything unless like there's a hole in it or you have it like there or not on there at all. Then you're gonna have problems, but otherwise it's perfectly harmless to have a metal one. You don't want to put just a nut there, and there. It's not gonna be too good for the board. It's gonna flex a little bit, and you could end up having, if an overheat happens, the board will split, which I've had happen twice, and it is not a good good thing. It's actually kind of dangerous if you're too close to the case, because this could end up touching the case, and well, actually no, this isn't there, but the motherboard could touch the case for a split second while there's electricity in it, and if you're accidentally touching the case or too close, you're in for a nasty little surprise there, and it's not good. There's also another benefit where heat's transferring to the heatsink, which that's what this is, but you got the back plate also on it, and the board's in between both of these. Now it's minimal, but because the board is touching both of these, heat's actually transferring to both. Which I wish companies would do this, but take the back plate and actually put a sort of heat sink on it for special cases that'll fit it and allow both sides of the CPU to be cooled. And even a special socket could be made to allow better heat transfer to both sides of the board. Now, moving on to heat sinks themselves. The main thing about heat sinks is surface area. The more surface area exposed to airflow, the better it's going to be at cooling. You're going to need to have a good cooler depending on what speed and how many cores your CPU or GPU or whatever type of processing unit on the board has. You don't want it to be too hot. Misconception, you don't want it to be too cold either. So proper heatsink selection is important. You can't just operate at 100 degrees Celsius. I'm going off Celsius because most boards tend to be default reading in Celsius. Personally, I wish they would use Kelvin instead of Celsius or Fahrenheit. It's a bit more scientific. Yeah, my bad. But anyways, so you can't just operate at 100 degrees, but you can't operate at negative 100 degrees either. There's a little bit of an area. I would suggest no more than 30 degrees on full load and no less than 10 degrees on full load. So basically in between 10 and 30 degrees, try to keep it in there unless you're overclocking. And by overclocking, I don't mean like a few, megahertz. I'm talking like 5 gigahertz, 6 gigahertz, some crazy something like that. Then you might want to keep it a lot more colder than you would normally want to do. But chances are you're not going to be doing that, so best to just go with the whatever keeps it cold as you need it to be. So, besides the heatsink, trying to keep it from shining so much into the camera. So, heat sinks are made from several materials. It can vary, but normally it's either copper or aluminum, and it makes contact. Now, see, it looks flat. Ignore the screws, please, because those screws are not the original. I had to take this thing off, lost the screws and all that. But it's not entirely flat, even though it appears. So you would need something like thermal paste, which there's some still on here. That's the stuff staining it. It's older thermal paste, and this thing needs to be cleaned, but I kept it on there for this video. Thermal paste makes it to where that non-flat surface fits just a bit better to where it makes perfect contact with the CPU. It basically allows proper heat transfer, and you basically actually allows this thing to cool to the best it can. Now, remember how I said about surface area? These fins, even though they're not connecting, provide far more surface area than just a block placed on the CPU. Because these copper pipes, these are heat pipes. They transfer heat from down here into this, from this block, down here into this block, up and into the actual heat sink. And because they're making contact with that properly, and that's making contact with the CPU properly, it allows the heat to go from the CPU up, 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 and your fan's blowing across this way. It allows it to cool it. And that's how a CPU works and what you would need to use it. And you just put that there and then screw it in. And you've just attached your CPU or your heatsink. Now, remember how I said there were different, shapes? This one is square. It's from an old Intel machine, and I absolutely hate Intel for this because your heatsink only works with certain socket types, which is extremely important because if you get the wrong CPU cooler and find out that your socket type does not support this cooler, you now have to either return this or buy a whole nother cooler. And here, I'm going to put these here for a moment to note the differences. This one is rectangular shaped, and this one is square shaped. Sometimes you'll find an aftermarket cooler, and it'll be an AMD with a square shaped, or an Intel with the rectangular shaped. But more times out of 10, I see the AMD CPUs and AMD CPU sockets using a rectangular shape, and the Intel ones using square. It's just something I noticed. It is not necessarily that way, but it varies. Now, we're on to another board. Oh, my bad. Now, this is from a laptop, and the reason I got a laptop instead of another desktop thing is to point out a few differences. This is a laptop RAM slot. It's kind of different from a desktop RAM slot, if you haven't noticed. This is going to seem kind of stupid or downright idiotic, but the laptop RAM sticks will not work in a desktop. The reason I am saying this is because I've had 3 people already ask me how to make laptop RAM work on a desktop. So I'm just saying that right off from the start. Alright, now on to a water cooler. This water cooler is a little bit larger, so I can't exactly fit it all in the shot, but this is the radiator section. Now, this radiator is kind of old. The pump is completely shot, so I don't mind about it being damaged, but it makes a perfect thing to point out for water coolers and how to properly, maintain them and whatnot. So, you can probably tell, you probably can't tell. It's kind of hard to see even with your eyes instead of a camera, but right here, these little tiny fins are big time bent. But right here, they are in a much better condition. And then right here, you can see where someone went like that and made holes in it. That is not good, but it's not too much of an issue. If you're real careful with, like, say, a flathead screwdriver, you can go in and just fix that right on up. It's looking a little better. If I put more time into it, it would look a lot better, wouldn't it? Now, the way these things work is they go from the pump, which is making contact with the CPU and pushes water through the pipes. These are the tubings. It goes into here, and then it goes right on up here, and then goes out and down. The way these things work is essentially like a heat sink, but instead of air, it's using water, which I find it much better if quiet is a must for you, which I really would suggest not having quiet be a priority, even though sometimes it could be warranted for like audio recording or stuff like that. But performance wise, it's not the best thing to have a priority in. But they're much quieter for the same cooling power. However, if you use fans that are also just as loud, you'll notice much more performance, which is why I always suggest a water cooler over a heat sink unless specific needs regarding sound in other hardware is needed. So, moving on. This here is the pump. And you remember how I said on the board there was the fans, the fan, ah, the fan plug or fan header, I've heard it called as well. It'll plug right into it. There's no need for a special plug or anything, but it'll fit in it. And this is a three prong, plug. It works just as well in a four prong. Another thing people have mentioned before, and it sorry if I sound a little irritated, but some of these things are really annoying when I hear, which is why I'm making the video to point those out. So just bear in mind with my stuttering, my agitated voice, my weird sounding voice today because I'm losing my voice. Great. Anyways, so on here, this will make contact just like a heatsink would, except inside here you have the actual pump. This one's a little bit fancier as it would push water up in there and blah blah blah. And it has a little light that light up in it and does a little pulse thing with the light. It goes slowly on, slowly off like that. But essentially, CPU makes contact, back plate on the back, water goes over this instead of air in there, and it transfers all that heat up into here. Which another benefit is it gets even farther away from the motherboard than a heat sink would just, do. So really these things have more than just cooling performance and quiet performance if that's what you want. Hey. But yeah, that's basically the difference between a heat sink and a water cooler. This is a processor. It is an AMD A644 4400, and it's dead. I can't use it. I actually had to replace it in a little laptop I use for when I'm on the go and don't want to game. Now, the die. The die is where the actual cores are. They're the little things that take data, process the data, and then send it on to wherever it has to go. So, I forgot what these little things are. I believe they are transistors. Transistors basically are on, off, yes, no, 1, 0, stuff like that. They're the most common component apparently in computers. And here's the thing, they don't all look the same. There are many components on the two boards I've shown you that are also transistors. I'm not an expert at identifying the small components on it, but they do come in multiple shapes and sizes and forms and all that. And I'm sure that even ICs have them in there too. I'm just pointing out the ones that I can recognize, the ones that are kind of important, and you want to be sure you know what they are, because it can help a lot. And I may sound like I know only half the stuff I'm saying, but bear with me. I've learned these things, but I haven't gone to like a college for it or a school. I've learned off of experience. I've learned off of forums and stuff like that. But anyways, bear with me here. Now, these little contacts, or not contacts, but the little contacts on the transistors. I can't. I have my laptop here. I'm trying to Anyways, I can't get it any better. I'm working with crapware right now because I'm not at my house. But these little things right here, you don't want to, short them out, right? Here's the thing. If you get thermal paste on here, it's not the end of the world. I mean, there's some stuck on it right now. But what shorted this thing out was the heatsink not even being on it. So it's not really a short out, more as it's a burnout. But if the thermal paste is not electroconductive, it will not harm the components. You don't have to worry about that. In fact, it's more likely good if you take the heatsink and like that and just put it right over it and have it touching both the die and those, because now it's cooling both and it's not shorting anything out because it's not electroconductive. So you really have nothing to worry about with that. Let me see. What else did I have to bring up? Yeah, I think that's about it. Um, Again, sorry for my voice. Currently been sick, and this is probably going to look bad considering this is my first video for this channel. But I might redo this thing later if I do end up uploading this rough version. Please note I will put a second video pointing out things I missed, rectifying any issues, which if I do post this version, I will also put the annotations, don't worry. Um, if these, if I messed anything up or pointed something else out wrong, please let me know. Also, if you're going to be one of those people who's like, hey, Saigon, you're not supposed to put the thermal paste on the transistors. It's gonna kill it. Please don't be that person. I mean, that, yes, that can cause an issue. However, if the thermal paste is not electroconductive, sir, it will not. It will only do that if it's going to conduct electricity. If it cannot conduct electricity, it cannot short it out. So, reiterating that again, you can't do that. It won't harm it, and you are good. And again, with the RAM thing, just to show y'all, I'm going to take some laptop RAM, and I'm going to do something you probably shouldn't ever attempt to do. Yeah, that does not work. And I shit you not, I've had 3 or 4 people, I think it was 3 people do this and say, "What's wrong with my computer? Please fix it." I can't fix fried hardware. You can't fix fried hardware. So, that's reiterated now. But yes, I mean, some of these things I probably got wrong, but please point them out. I love learning about computers, and I love making sure I don't get this stuff wrong. I mean, I go over the top on the smallest scale of things because my gaming rig at home, I want it to squeeze every little bit of performance out of it like it's a sponge. And knowing these small things is kind of useful for that. For example, take one of those thimbles that people who sew with, they put it on the fingertips to prevent the needle from stabbing into their fingers and all that. Take thermal paste, coat it around a capacitor, put that over it. You're now cooling your capacitor. I mean, it seems like a small thing, but if you're cooling your CPU, and motherboards will do this too, they'll cool the VRMs. Another way. They'll cool the VRMs. I mean, they cool it for a reason. Why not go ahead and cool the capacitors that are involved with the VRMs? Why not go ahead and cool the other smaller chipsets? The ICs. Cool these. Cool the BIOS. You can't really cool the chokes because it's exposed wire, and I'm not sure if they put an ammo on the chokes wire or not. But chances are, if they don't, you don't want to mess that up. Um, let's see. Yeah, just if it if it's having electricity go through it and you're pushing it for performance, go ahead and cool it. And that goes for anything on the board. Even if you're not, I would suggest do it to some extent, like on the tops of the capacitors. Just take a penny, put it on top after putting some thermal paste, and just have airflow go over it. It's going to cool it a little bit. And just knowing these little components helps that. But this video has been kind of long, and I'm going to cut it short. So, yeah, this is my first video. First one I've ever made, actually. But I hope it was helpful, very informative for you. If I got something wrong, just let me know what it was. And yeah, I'm going to sign off and get to work uploading this thing and then putting annotations in, the description, and all that. See you later.